Okay, so now that we've run through this process of a hypothesis test, it's now important that we actually run through a whole one in one step, right? We kind of march through that. And ultimately, we want to find out, is something statistically significant? And so let's look at this example here, where it says the percentage of college graduates in the nation who have LinkedIn accounts is 32%. 275 graduates from a particular college had 38% of graduates with a LinkedIn account. How many standard deviations above the overall percentage is this particular college, right? And so in order to think about what that is, we're going to think about this as a hypothesis test, right? And so this idea, how many standard deviations above the overall percentages, is going to be our test statistic. And see, I can calculate that there. But we see that the null and alternative hypothesis in this case is that the proportion of graduates is 32. And we're going to check to see if it's greater than 32. We have some sample data, and this data that we have, right, this is the data that from this college is 38%. And so the test statistic would be this calculation over here, right? And that came from our equation we have. And so you end up getting a test statistic of 2.13, right? It's 2.13, really standard errors instead of standard deviation, right? Above, right? Above the population proportion, 0.32. And so what is the probability, right, of a school having this high, this much higher than the national rate? What is this probability, right? And so once we have that, we use the normal calculator. You would put in z greater than 2.13 and you get this value here. So what does this value mean again? I wrote it over here on the side. There is a 1.66% chance we would see this outcome, right? If the national percentage really is 32% or 0.30, that we would get this sample data, right? There's a 1.6% chance. Since that value is low, right, would we say this is statistically significant? Well, using, right, and this goes back to this statement here, something statistically significant. So if we use, sorry about that, if we use an alpha equals 0.05, right, then what do we know? This is statistically significant. Statistically significant. We know that's the case if we use alpha. Sorry, let me fix that we. Right, and that's again because the p-value is low, and then we went back to how low? Well, we end up defining that, right, by using the alpha. And so then that comes again back to here. We normally use a level of significance of 0.05 or 5%. Right, and that's, again, the basis of how we run a hypothesis test and make conclusions. And we can then make some conclusion here that since this p-value is low, right, the probability of this happening, it may be true, right? We may then have to reject this idea that the null hypothesis is true, right? Because we observed something that was unusual, something that again, back here, had a small chance of happening. It was unlikely just by chance. And so we would make a conclusion. And so in this case here, for this example, right, how would we write a conclusion in this case? Right, we have a decision. If your p-value is smaller than or equal to alpha, if your p-value is greater, we come to a conclusion and say we reject, right? We will reject the null hypothesis. Right, and you can see that there. If the p-value is greater than alpha, then we come to a conclusion and say we fail to reject the null hypothesis. Since the p-value, right, since the p-value, and on this specific case, since the p-value that we have of our sample data is less than alpha, right, it's less than 0.05, we're going to use that, remember that's a standard value. We say reject the null hypothesis. If it's not, we'll fail to reject. And so our conclusion, right, this is what we would say statistically significant, but our conclusion, we can say that, but our conclusion is always a sentence that follows this form over here. And then our conclusion here would be that there is sufficient and we're using this one because our p-value is less than the 5%. There is sufficient evidence to show that, to conclude, there is sufficient evidence to show, there's other ways you can word it, but it always follows this form. There is sufficient evidence to show that, and then you always put the context of the alternative. In this case, the alternative is that the proportion of graduates is greater than 32%. Not graduates, but the proportion of graduates with LinkedIn accounts, and we're referring to this here, right? LinkedIn accounts is greater than, and that's what we have. And that's how we finish a hypothesis test.